Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 7 has been released, right? So in this video, I'm going to discuss the solution of mock test 7, question number 121 to 150. So if you haven't downloaded the paper, please join the WhatsApp channel using the link which is given in the description box. In there you will get the question papers, okay? All the mock tests. Yeah. So question number 121. With what velocity should a particle be projected? Should particle be projected so that its height becomes equal to radius of the earth? Okay. So this is the earth, right? Isn't it? So here you gave velocity u to the particle of mass m, small m, okay, so that it reaches height h. Okay, it reaches height h. The value of h, that is the height, is equal to radius of the earth. Okay, height becomes radius of the earth, right? So here we need to apply the conservation of energy theorem, right? Why? Because there is no external force acting on our system, right? So what is our system? Our system is particle and earth, right? So there is no external force acting on our system, we can conserve the energy, right? So now apply conservation of energy theorem. Initial total energy is equal to final total energy. Final total energy, right? So what is the initial total energy? Initial total energy is kinetic energy of the particle, right? Plus potential energy of the particle. Okay. So potential energy is potential energy of the particle on the surface of the earth, right? Here r is the radius of the earth, isn't it? So kinetic energy of the particle, half m into u square. U is the velocity given to the particle, okay, minus the gravitational potential energy of the particle, that is g mm divided by r, right? Minus gmm divided by r is equal to final potential energy of the particle. Here final potential energy of the particle is minus gmm divided by 2r, right? Plus kinetic energy of the particle, that is 0, right? Okay. So now we need to find the value of u, right? So half mu square is equal to g mm divided by 2r, right? M will get cancelled, isn't it? And 2 will also get cancelled. Finally u is equal to root of g into m divided by r. So the correct option is A. Okay, root of gm by r. Next question, question number 122. A ball is falling in a lake of depth 200 meter, creates a decrease 0.1% in its volume at the bottom. The bulk modulus of the material of the ball will be. Here we need to find bulk modulus of the material of the ball. So B equal to here minus dp divided by dv by v, right? This is bulk modulus, right? So minus dv by b is decrease in volume, right? Isn't it? So that is 0.1%. 0.1 is here 0.1% is 0.1 divided by 100, right? Bulk modulus B is equal to, here change in pressure is h into rho into g, right? dp is h into rho into g divided by 0.1 by 100, that is 10 to the power minus 3, right? So B equal to, h is 200 meter, right? 200 into rho. Rho is density of the water, so 10 to the power 3 into g. G is 9.8, right? Into 10 to the power 3. 1 by 10 to the power minus 3 is 10 to the power 3. Now bulk modulus B is equal to, here 10 to the power 3 into 10 to the power 3 is 10 to the power 6 into 10 to the power 2, that is 10 to the power 8. Here 9.8 into 2 is 19.6. 19.6 into 10 to the power 8 Newton per meter square. So the correct option is A. Okay. Yeah. Next question. Question number 123. A ring of mass 10 kg and diameter 0.4 meter, that is radius equal to 0.2 meter, here mass equal to 10 kg, is rotated about its axis if it makes 2100 revolution per minute, then its angular momentum will be about. Okay, we need to find angular momentum L, right, which is equal to moment of inertia of the ring into omega, right? So what is the moment here? Moment of inertia of the ring about which axis? About the center of the ring, right? Now L equal to moment of inertia of the ring about its center is m into r square into omega. We know m, we know r, so we need to find the value of omega, right? Now L is equal to, here mass of the ring is 10 kg, 10 into r square is 0.2 squared, 0.2 square is 2 into, here 0.2 square is 4 into 10 to the power minus 2, okay, 4 into 10 to the power minus 2 into omega. Omega is 2100 into 2 pi divided by 60, right? So here they have given number of revolutions per minute, right? So how to find omega? Omega equal to number of revolutions per minute, n into 2 pi. 2 pi is the 2 pi radian. 2 pi radian is 1 revolution, right? So n into 2 pi divided by time t. T is here 60 second, right? In minute, right? So it will be 60 second. So 0, here 10 will get cancelled, right? 2 3s are 6, so 3 7s are 21, right? So here 70, right? 210 by 3 is 70, right? Isn't it? So L is equal to here 10 into 4 into 10 to the power minus 2 into 70 into pi, right? So the value of L is equal to, here 10 to the power minus 2 into 10 is 10 to the power minus 1, right? So 70 into 4 is 280. So 280 into pi into here 10 to the power minus 1, right? So L equal to, here 28 into pi into, 28 pi, right? 28 pi, isn't it? 28 pi. So now L is equal to 28 pi is approximately equal to 88, right? 88 kg meter square per second. 88 kg meter square per second. Okay, so the correct option is B. Next question, question number 124. A thin liquid film formed between a U-shaped wire and a light slider supports a weight of 1.5 into 10 to the power minus 2 Newton. So this is the given figure, right? Here this is the U-shaped wire, right? And thin film is there, soap film is there. Okay. Here this is the movable wire. Okay. So it is attached to a weight of 1.5 into 10 to the power minus 2 Newton, right? The length of the slider is 30 centimeter. Here the length L equal to 30 centimeter, right? And its weight negligible. Weight of the slider is negligible. The surface tension of the liquid film is simple, right? So this is at equilibrium, right? Isn't it? Here this is at equilibrium. So the force of surface tension is equal to weight, right? So force of surface tension is equal to weight, right? So what is the force of surface tension? The force of surface tension is here 2L into S, right? Why it is 2L? So there are two surfaces, right? One the front side, another one is back side, right? So there are two surfaces. So 2L into S. S is surface tension equal to W, that is weight. So S equal to W divided by 2L. So now substitute the values. Here S equal to W is 1.5 into 10 to the power minus 2 divided by 2 into L. L is, here what is the value of L? L is 30 centimeter. That is 3 into 10 to the power minus 1, right? Now 1.5 by 3 is 1 by 2, right? 2 into 2 is 4. So S is equal to, if you solve this, you will get 0.025 Newton per meter. Okay, so the correct option is D. Okay, next question. Question number 125. The ratio of the coefficient of thermal conductivity of two different materials is 5 by 3. That is K1 divided by K2 is equal to 5 by 3. If the thermal resistance of the two rods of these materials of same thickness is same, so R1 is equal to R2. Thermal resistance of the two material of the two rods of these materials of the same thickness is same. Okay, then the ratio of the length of these rods will be, we know that thermal resistance R equal to L divided by Ka, right? So R1 is equal to L1 divided by K1 into A, right, which is equal to L2 divided by K2 into A. Thickness is same, right? So now K1 divided by K2 is equal to L1 by L2, right? So what is K1 by K2? 5 by 3. So the ratio of their length L1 is to L2 is equal to 5 is to 3. So the correct option is A. Okay. Next question. Question number 126. A gas at the temperature 250 Kelvin is contained in a closed vessel. If the gas is heated through 25 K, that is Kelvin, then the percentage increase in its pressure will be. Okay. Here the gas at the temperature 250 K is contained in a closed vessel, right? Isn't it? So the volume remains constant. Ideal gas equation PV equal to nRT, right? So P equal to nR divided by V into T, right? We need to find change in pressure, right? So change in pressure in percentage, that is delta P divided by P in percentage is equal to delta T by T in percentage, right, into 100%, isn't it? Okay, so now the change in pressure, right, here delta P by P into 100%. Okay, I will write delta P by P into 100%. Okay, so now what is the change in temperature? Change in temperature is 25 Kelvin, right? Here if the gas is heated through 25 Kelvin, that is 252 to 275, 275 minus 250, that is 25, right? So delta P divided by P into 100%, which is equal to 25 divided by T. T is 250 into 100%, right? So now 25 by 250 is 1 by 10, right? So 100 by 10 is 10. So change in pressure in percentage is equal to 10%, right? 10. Change in pressure in percentage is 10. So the correct option is A. Okay. Yeah. Next question. Question number 127. If Q, E and W denote respectively the heat added, change in internal energy and the work done in a closed cyclic process, then. Okay. In a closed cyclic process, Q equal to W, right? And the change in internal energy E equal to 0. Okay. Why it is 0? Because here it returns to the same thermodynamical state, right? Isn't it? So that's why change in internal energy is 0. So the correct option is A. Okay. Next question. Question number 128. A hollow sphere is filled with water. Okay. Hollow sphere is filled with water. It is hung by a long thread. As the water flows out of a hole at the bottom, the period of oscillation will. Okay. So let us draw the diagram. Here, this is the hollow sphere. Okay. It is connected to a long thread. Okay. Now effective length is L. Okay, effective length is this one. Okay, from the center of mass or center of gravity to the point of suspension. Okay, yeah. So it is filled with water, right? Isn't it? It is filled with water. So here at the bottom, okay, as the water flows out of a hole at the bottom, right? So this is the bottom. The water is flowing out from this bottom, right? We need to find the period of oscillation. Here time period of the oscillation t equal to 2 pi into root of L divided by G, right? L is effective length, okay? Effective length. Effective length. Okay. So now T, that is period of oscillation, is directly proportional to root of effective length, right? Okay. So as water flows out from this hole, what happens? The center of mass will start to shift in downward direction, right? Center of mass will start to shift in downward direction, isn't it? Isn't it? Or center of mass will start to move towards downward direction, right? We know that center of mass lies on the heavier side of the object, right? Isn't it? Isn't it? So center of mass will start to move in downward direction, isn't it? Right? So now when water level reaches somewhere here, okay, somewhere here, center of mass will start to move in upward direction. Why? Because this part is heavier side, this part is lower side, right? So this part becomes the lighter side, not lower side, lighter side, and this part becomes heavier side, right? So center of mass will start to move in upward direction, right? So that is, first center of mass moves in downward direction, that is effective length increases, right? Then center of mass will start to move towards in upward direction, or center of mass moves in upward direction, okay, it will move in upward direction. So the effective length will be lesser, okay, effective length decreases, okay. So time period is directly proportional to root L, right? So period of oscillation, initially it increases, first it increases, then it will decreases, isn't it? Then it will decreases. So option A says first increases and then decreases. Correct. Option A is the correct answer, right? Yeah. Next question. Question number 129. What type of vibrations are produced in a sitar wave? Okay. When vibration produces in a sitar wire, okay, so superposition takes place, right? Isn't it? Superposition takes place between, here superposition of wave takes place between incident and reflected wave, right? Incident and reflected wave, right? So this is the new wave, right? New wave is produced, right? So there will be a superposition of the wave between, superposition takes place between incident and reflected wave at the rigid end, right? So this is the rigid end, isn't it? So now this new wave is called as stationary wave, okay? Your new wave in the medium is called as stationary wave, and its nature is transverse, okay? Its nature is transverse. So the correct option is C, stationary and transverse, okay? Yeah, next question, question number 130. A hollow cylinder has a charge Q coulomb within it. Okay, so this is the hollow cylindrical cylinder, okay, has charge Q coulomb, right? Has charge Q coulomb. If phi is the electric flux in units of voltmeter associated with the curved surface B, here phi is the electric flux, okay, associated with B, okay, electric flux through this the surface B is phi. The flux linked with plane surface A in units of voltmeter will be, okay, we need to find flux linked with A, right? So now what is the total flux? Here the total flux is equal to flux linked with A plus flux linked with C plus flux linked with B, right? Flux linked with A plus flux linked with C plus flux linked with B. Here phi is the flux linked with B, right? So phi total, that is total flux, is Q divided by epsilon naught, right? Which is equal to flux linked with A, which is equal to flux linked with C, right? Isn't it? I can write flux linked with A equal to flux linked with C equal to phi dash, right? So now this will be phi A plus phi C will be 2 phi dash, which is equal to, sorry, 2 phi dash plus phi, right? 2 phi dash plus phi. So what we need to find? Here we need to find phi dash, that is flux linked with phi A, right? So flux linked with A, that is phi dash, is equal to here 1 by 2 into Q divided by epsilon naught minus phi. This is the final answer. Okay, so the correct option is D. Next question, question number 131. There is an electric field E in x direction if the work done on moving a charge of 0.2 coulomb through a distance of 2 meter along a line making an angle 60 degree with the x-axis is 4 joule, then what is the value of E? Okay, here work done by electric force is equal to Fe into S cos theta, right? So what we need to find? Here we need to find the value of E, right? So what is Fe? Fe is Q into E, W equal to QE S cos theta, right? E equal to W divided by Q into S cos theta, right? Here there is an electric field in x direction. This is the direction of the electric field, right? Electric field. If the work done on moving a charge of 0.2 coulomb, right? 0.2 coulomb charge, it moves through a distance of 2 meter along a line making an angle 60 degree with x-axis. So this is how charge moves, okay? Here the distance is 2 meter, angle is 60 degree, okay? Now we need to find the value of E, that's it. So we have the equation, right? Here theta is angle between E and S, right? So E is equal to W, W is 4 joule, right? W is 4 joule. Here distance of 2 meter along line making an angle 60 degree with the x-axis is 4j. The work done is 4j, right? 4 joule. So 4 divided by Q, Q is 0.2 coulomb into S, S is 2 meter into cos theta, that is cos 60 degree. Cos 60 degree is 1 by 2, right? So 1 by 2, here 2 divided by 2 will get cancelled, right? So 4 by 0.2. So E equal to 4 divided by 0.2, right? So E equal to 20 Newton per coulomb. 4 by 0.2 is 20 Newton per coulomb, okay? So the correct option is D, okay? Next question, question number 132. Two opposite charges of magnitude Q are placed at the ends of side L of a square of side 2A. Here square, okay, Q and Q, okay, two positive charges magnitude of Q are placed at the ends of a side L of a square of side 2A. Two negative charges of the same magnitude are kept at the other corners. Here negative Q and negative Q are placed at the other corners. Starting from rest, if a charge Q moves from the middle of the side L, if charge capital Q moves from the middle of side L to the center of the square. Here middle of the side L to the center of the square. Okay, center of the square. Its kinetic energy at the center of the square is, okay, we need to find when charge moves to the center of the square, when charge moves to the center of the square from the middle of side L. Okay, here this is 2a, it has side 2a. Okay, from the middle of the side L to the center of the square. So we need to find the kinetic energy of this q at the center of the square. The direct question, right? How it is direct? See here, first we need to find the potential energy of the q at this point, that is middle of this total side 2a, right? And then potential energy at the center of the square. Then take the potential difference, potential energy difference. Okay. Now, what is the initial potential energy? Initial potential energy is potential energy of the q at this point, right? So initial potential energy is potential energy of the q due to this q, that is k into q divided by k into capital Q into small q divided by L equal to A, right? So how we got this formula? Here the electrical potential energy U equal to Q into potential V, right? Q into potential V. So Ui equal to K Q into Q divided by A, potential energy of Q due to this Q, plus potential energy of Q due to this Q, that is K Q Q, potential energy of this capital Q due to small q. So this will be KQQ divided by A, right? Minus, okay, actually it is plus. I am writing minus because we have negative charge, right? Potential energy of Q due to minus Q, that will be K into Q, K into Q into minus Q. So plus into minus is minus, right? K into Q divided by, what is the distance between minus Q charge and plus Q charge? Here this is equal to A, right? This is 2A. Apply Pythagoras theorem, you will get root 5A, right? So this will be root 5A. Okay. So again potential energy of Q due to this minus Q, right? The same value we will get. So multiply 2. Okay. Now initial potential energy is equal to 2 times KQQ divided by A, right? Into 1 minus 1 divided by root 5, right? So this is the initial potential energy. What is the final potential energy? Here the final potential energy is potential energy of the q at this point, right? So what is the final potential energy? Here the potential energy of the q at this point, right? That is the center of the square, right? So that will be UF is equal to here K Q potential energy of Q at this point due to small q. So KQQ divided by, what is the distance here? This distance. This is A, right? This is A. So what about this one? So this will also be A, right? So if this is A and this here, this, let's say this side is, okay, this is point P and A. AP is A, right? This is C. PC is also A, right? So what is the value of AC? AC is root 2A, right? So this will be root 2A. So there are two positive charges, right? The distance is also same. Magnitude is also same. So multiply 2. Now minus 2 KQQ divided by same thing, right? Root 2A. So it will be 0. So final potential energy is equal to 0, right? Now we need to find the kinetic energy, right? So here the kinetic energy is change in potential energy, right? Isn't it? So change in potential energy is equal to kinetic energy, right? So what is the change in potential energy? Change in potential energy is this one, right? UF minus UI. UF minus UI is here this one, 2 times KQQ divided by A into 1 minus root 5. So which is equal to kinetic energy, right? Isn't it? So which is equal to kinetic energy. Here you have to write in negative sign. Okay, ui is negative 2 times 2 kqqq divided by a. Okay, uf minus ui, right? Uf is anyway 0, minus of minus 2kqqq divided by a into 1 minus 1 by root 5 is plus 2kq into q divided by a into 1 minus 1 by root 5, right? So kinetic energy is equal to here 2, here 1 divided by 4 pi epsilon naught into 2qq divided by here a divided by a divided by a divided by a into 1 minus 1 by root 5. Okay, this is the final answer. So the correct option is B, right? Sorry, the correct option is A, 1 divided by 4 pi epsilon naught 2qq divided by a into 1 minus 1 by root 5, right? So the correct option is A. Yeah, next question, question number 133. Two spheres A and B of radius 4 centimeter and 6 centimeter, here RA equal to 4 centimeter, RB equal to 6 centimeter, are given charges of 80 microcoulomb, 40 microcoulomb respectively. If they are connected by a fine wire, the amount of charge flowing from one to other is. Okay, so here two spheres, right, of radius 4 centimeter and 6 centimeter, right? Initial charge on sphere A is 80 microcoulomb, right? The radius is 4 centimeter. Initial charge on sphere B is 40 microcoulomb, right? 40 microcoulomb. The radius is 6 centimeter. Now these two are connected by fine wire. Okay, we need to find the amount of charge flown, right? Flown from one to the other, right? Here some charge will move, right? Isn't it? From one to other. So when charges moves, here the charge on sphere A comes from 80 microcoulomb to QA. Okay, and charge on sphere B comes from 40 microcoulomb to QB. Okay, so charge will flow, there will be a flow of charge till the potential of A equal to potential of B. Okay, so that is KQA by RA is equal to KQB by RB. Okay, so now QA divided by QB is equal to RA by RB, right? So here, according to conservation of charge, initial total charge equal to final total charge, right? So initial total charge Q equal to QA plus QB, right? So initial total charge is Q, final total charge is QA plus QB. Okay, so now here we can easily find Q and QB, right, using this equation. Okay, then substitute here. Now here I can write this equation as QA equal to QB into RA divided by RB, right? So now Q is equal to, here QA is QB into RA divided by RB into, plus QB, right? So here QB is equal to capital Q into RB divided by RA plus RB, right? Similarly, if you follow the same method, then you will get QA is equal to Q into RA divided by RA plus RB, right? So now substitute the values. Here QA is equal to, capital Q is 120 microcoulomb, that is initial total charge. So 120 into RA is 4 centimeter, right? So 120 microcoulomb into 4 centimeter divided by RA plus RB 10 centimeter. Centimeter will get cancelled, right? So 10 12s are 120. So the value of QA is equal to 48 microcoulomb, right? Value of QA is equal to 48 microcoulomb. Okay. So now what is the value of QB here? The QB is equal to 120 into 6 divided by 10, okay, which is equal to 72 microcoulomb. Okay. So after connecting the wire between A and B, spheres A and B, the charge on sphere A becomes 48 microcoulomb and sphere B becomes 72 microcoulomb, isn't it? So here some amount of charge flown from A to B, right? So what is the amount? The amount is 32 microcoulomb, right? Here 32 microcoulomb flown from A to B, right? 32 microcoulomb flown from A to B. Okay. So the correct option is D. Next question, question number 134. 4 charges Q1, Q2, Q3, Q4. Okay, values of the Q1, Q2, Q3, Q4 are given, are placed at 4 corners of square of side √2 meter. What is the potential at the center of the square? Okay, so this is the square. Okay, so Q1, Q2, Q3 and Q4 charges are placed at the corners of the square, right? 4 corners of the square. Side of the square is √2 meter. So what is the potential at the center of the square, right? Potential at the center of the square we need to find, right? So potential at the center of the square is potential due to Q1, potential due to Q2, potential due to Q3, potential due to Q4. Okay. So potential at the center of the square is potential at the center due to Q1, potential at the center due to Q2, potential at the center due to Q3 and potential at the center due to Q4. Okay. So now potential at the center of the square is equal to, what is the potential due to Q1? So potential due to Q1 is K into Q1 divided by, what is the distance between Q1 and center of the square? Here the side is √2 meter, right? Isn't it? Side is √2 meter, right? So what is the half of √2 meter? Half of √2 meter is 1 by √2, 1 by √2 meter, right? So this is the diagonal, right? Isn't it? So here the angle is 45 degree, right? Here the angle is also 45 degree, right? So now here cos theta is equal to base by hypotenuse. Okay, base divided by hypotenuse, let's say x. Okay, now x is equal to cos 45 degrees 1 by √2, right? So b base is 1 by √2 whole divided by 1 by √2 by cos theta. Cos theta is cos 45 degree, cos 45 degree is 1 by √2. So 1 by √2 will get cancelled. So x equal to 1 meter. Okay, so now this distance is equal to 1 meter. The half of the diagonal is equal to 1 meter, right? Now the distance between Q1 and center is 1, right? Plus potential due to Q2 is K into Q2 divided by 1. Potential due to Q3 is K into Q3 divided by 1, plus potential due to Q4 is K into Q4 divided by 1, right? Now Vc is equal to K is 9 into 10 to the power 9. Take K as common. So K is 9 into 10 to the power 9 into Q1 plus Q2 plus Q3 plus Q4. So what is the value of Q1? Q1 is 2 into 10 to the power minus 8, right? Here 10 to the power minus 8 is there for every charges, right? So I can take 10 to the power minus 8 as common, right? So Q1 is 2 into 10 to the power minus 8, Q2 is minus 2 into 10 to the power minus 8, Q3 is minus 3 into 10 to the power minus 8, Q4 is plus 6 into 10 to the power minus 8. Okay, now Vc is equal to, here 2 minus 2 is 0, right? 6 minus 3 is 3 plus 3, right? So 9 into 3 is 27. So 27 into 10, which is equal to, here 10 is 10 to the power 9 into 10 to the power minus 8, which is equal to 270 volt. So at the center, the potential is 270 volts. So option A is the correct answer. Okay. Question number 135. A parallel plate capacitor has a plate area of 50 centimeter square and plate separation of 1 centimeter. A potential difference of 200 volt is applied across the plates with air as the dielectric between the plates. Okay, this is the parallel plate. Okay, the area of the parallel plate capacitor is 50 centimeter square. Okay, separation between the plates is 1 centimeter. Okay, potential difference across between the plates, applied potential difference is 200 volts. The battery is the disconnected and the piece of bakelite of dielectric constant 4.8. So here the value of K is equal to 4.8 inserted, which fills the complete volume between the plates. The capacitance before and after inserting bakelite are respectively. Okay, that is, we need to find capacitance of the parallel plate capacitor when there is no dielectric, and capacitance of the capacitor when there is a dielectric. Okay, so let us find C, that is capacitance of the capacitor when there is no dielectric, that is air as a dielectric. So C equal to epsilon naught A divided by D. This is the capacitance formula for parallel plate capacitor, right? Now here C is equal to epsilon naught. The value of epsilon naught is 8.85 into 10 to the power minus 12 into A. A is 50 centimeter square, that is 50 into 10 to the power minus 4, divided by the separation between the plates is 1 centimeter, that is 10 to the power minus 2 meter, right? So now solve this, you will get C equal to 4.4 picofarad. Okay, 4.4 picofarad. Let us find C dash. C dash. Okay, C dash. This is not C double dash. Okay, C dash is equal to K into C, right? So C dash is equal to, actually C dash is K into epsilon naught into A divided by D. So we already found the value of C, right? That is epsilon naught A by D. So now multiply K, that's it. So now C dash is equal to 4.8 into 4.4 picofarad, right? So now what is 4.8 into 4.4? 4.8 into 4.4 is 21.1, right? So C dash is equal to 21.1 picofarad. Okay. Now here the value of C is 4.4 picofarad. So option D is eliminated. Okay. Value of C dash is 21.1 picofarad. So the correct option is C. Okay. Next question. Question number 136. Two positive ions. Okay. Two positive ions. Each carry a charge Q. Each carry charge Q are separated by a distance D. Separated by distance D. If F is the force of repulsion between them, okay, F is the force of repulsion between these two charges, that is K Q square divided by D square. The number of electrons missing from each ion will be, here these two are positively charged ion, right? Isn't it? Right? So that is, number of electrons are here, the electrons are removed from these two positive charges, so these two positively charged ions, right? Here the number electrons are removed from these two positively charged ions, right? Isn't it? Isn't it? Then only the ions, these two ions will charge positively, right? Or it will gain positive charge, right? So here the charge of the positive, here the charge of these two ions Q equal to N into E, right? N into E is the total charge of the removed electron or missing electron, right? Which is equal to charge of this positively charged ion, right? Or two positive charge ion. Q is charge of this ion, right? Positive ion, right? Q equal to N into E, right? So which is equal to total charge of the missing electron. Now F equal to K into Q is N into E, N square E square divided by D square. K is 1 by 4 pi epsilon naught, right? So here F into d square divided by k into e square equal to n square. So the value of n is equal to 4 pi epsilon naught f into d square, 4 pi epsilon naught f into d square divided by e square to the power 1 by 2, or here the square root of 4 pi epsilon naught f d square divided by q square or e square. Okay, so the correct option is C. Okay, yeah, next question, question number 137. The electric field intensity just sufficient to balance the Earth's gravitational attraction on an electron will be. Here mass of the charge is given, right? Mass of the particle is given. Okay, here what is the particle? The particle is electron, right? So mass of the electron and charge of the electron is given, right? And g is also given, gravitational acceleration due to gravity, right? So this is the electron, right? Here the weight of the electron is mg. It is balanced by electric field, right? So it is balanced by electric force, okay? Q into E. Now electric force is equal to mg. So what is electric force? Minus E into E, which is equal to m into g. Now E is equal to mg by E, mg by minus E. Now E equal to m is 9.1 into 10 to the power minus 31 kg into g is 10 meter per second square divided by minus E minus 1.6 into 10 to the power minus 19 Coulomb. Okay, now E is equal to here 9.1 divided by 1.6, that is 4.8. Okay, sorry, here 9.1 divided by 1.6 is 5.6. Okay, 5.6 into 5.6 into 10 to the power minus 11, right? 10 to the power minus 11 Newton per Coulomb. 5.6 into 10 to the power minus 11 Newton per Coulomb. So this is the electric field and negative sign is there. Okay, so the correct option is A. Okay, the correct option is A. Next question, question number 138. At room temperature, copper has free electron density 8.4, free electron density of 8.4 into 10 to the power 28 per meter cube. That is the value of n equal to 8.4 into 10 to the power 28, 8.4 into 10 to the power 28 per meter cube. That is n, small n, which is equal to n by v. Okay. The copper conductor has cross section of 10 to the power minus 6 meter square. That is, area of cross section of the copper is 10 to the power minus 6 meter square and carries a current of 5.4 ampere. Here I equal to 5.4 ampere. The electron drift velocity in copper. Okay, drift velocity in copper Vd is equal to I divided by NEA, right? So this is the formula of the drift velocity in terms of current. Now drift velocity Vd is equal to I is 5.4 divided by N is here 8.4 into 10 to the power 28 into E is charge of the electron 1.6 into 10 to the power minus 19 into A is 10 to the power minus 6 meter square, right? So now solve this, you will get 0.4 millimeter per second. Okay, drift velocity of the electron is 0.4 millimeter per second. So option C is the correct answer. Okay, question number 139. The powers of two electric bulbs are 100 watt and 220 watt. Both of them are joined with 220 volt. The ratio of the resistance of their filament is, okay, here the power of the two electric bulbs are 100 watts and 200 watts, right? So P1 is equal to 100 watt, P2 is equal to 200 watt, right? So we need to find the ratio of the resistance of their filament. We know that power P is equal to both of them joined with 220 volt, right? So power P equal to V square divided by R, right? Now here power P1 is equal to V square divided by R1, power P2 is equal to V square divided by R2. Okay, P1 equal to V square by R1, P2 is equal to V square by R2. Now here R1 is equal to V square by P1, R2 is equal to V square by P2. Okay, so now take the ratio of R1 and R2. R1 by R2 is equal to, here V square will get cancelled, right? Isn't it? So R1 is V square by P1, R2 is V square by P2. So V square will get cancelled, right? So R1 by R2 is equal to P2 by P1. Now R1 divided by R2 is equal to P2 by P1. P2 is 200 watt divided by P1 is 100 watt. So now the ratio R1 is to R2 is equal to 2:1. So the correct option is D. Okay. Next question, 140. The graph shows the variation of resistivity with temperature T. The graph can be. Okay. Here this is the variation of temperature, variation of the resistivity with temperature. Okay. So here the first option says copper. So this graph represent for copper. This one is wrong, right? Isn't it? Why? The copper is a conductor, right? Good conductor. So what is the graph of resistivity versus time? Sorry, the temperature. The graph for conductor, the graph of resistivity versus temperature graph, okay, for conductor is like this. Okay, resistivity versus temperature graph for conductor. Okay, here copper, nichrome and silver, these are conductors, right? And germanium is a semiconductor. Okay, for semiconductor, resistivity versus temperature graph is like this. Okay, so option C is the correct answer. Okay, option A, B and D are wrong. So the correct option is C. Next question, question number 141. The resistance of a wire at room temperature 30 degrees Celsius is found to be 10 ohm. Okay, so here the resistance of a wire at room temperature 30 degrees Celsius, okay, delta T equal to 30 degrees Celsius. Okay, so R equal to 10 ohm. Okay, here R naught is the resistance of the wire at a reference point or reference temperature. Okay, so delta T is 30 degrees Celsius minus reference temperature. Now here there is a full stop. Okay, now to increase the resistance by 10%, here we need here to increase the resistance by 10%. What is the 10% of 10 ohm? 1 ohm, right? So R dash is equal to 11 ohm, right? 10 plus 1, that is 11 ohm. The temperature of the wire must be, here we need to find the temperature of the wire, delta T dash. The temperature coefficient of resistance of the material of the wire is 0.002 per degree Celsius. Okay, per degree Celsius. This is the value of alpha. Okay, so at room temperature 30 degrees Celsius, the resistance of the wire is 10 ohm, right? Now we know the formula for temperature dependence of resistance, right? That is R equal to R naught into 1 plus alpha into delta T, right? Here R equal to 10 ohm, right? So here 10 is equal to R naught into 1 plus alpha into delta T, right? Next 11 ohm is equal to R naught into 1 plus alpha into delta T dash, right? Delta T is 30, right? So now take the ratio or divide second equation by first equation. Okay, so 11 divided by 10 is equal to, 11 divided by 10 is equal to, here R naught will get cancelled, 1 plus 30 alpha, okay, sorry, 1 plus alpha into delta t dash. Okay, 1 plus alpha into delta t dash divided by 1 plus 30 alpha. Okay, so the value of alpha is given, right? Isn't it? Now 11 into 1 plus 30 alpha is equal to 10 into 1 plus alpha into delta t dash. Okay, the value of alpha is given, right? So now solve it, you will get delta t dash. Okay, delta t dash is equal to 83 degrees Celsius. Okay, 83 degrees Celsius. Solve this. Okay, simple mathematics, elementary mathematics. So option B is the correct answer, 83 degrees Celsius. Next question, question number 142. See the electric circuit shown in the figure. Which of the following equations is correct equation for it? Okay, so this is the given circuit, right? Isn't it? So let's apply KVL to the first loop and KVL to the second loop. Okay, so then we will get the two equation. So we have to check which equation is the correct equation. Okay, or which equation the correct equation we got. Okay, so now the KVL for first loop. Okay, here this is the direction of the loop, right? That is the clockwise. This is the direction of the current, right? Here I1 plus I2, I1 plus I2. Okay, now here we are moving from lower potential to higher potential, right? So now this will be plus E1, plus E1. This will be plus E1, right? Plus E1. Next, this is the direction of the current, right? Isn't it? The direction of the current and direction of the loop is same, right? The direction of the current and the direction of the loop is same, right? Isn't it? So now the potential difference across R1 will be minus I1 plus I2 into R1, right? Isn't it? So now here this is I1, right? So the direction of the loop and the direction of the current is same, right? Isn't it? So potential difference across small r1 is minus I1 into R1, which is equal to 0. Okay, so this is the KVL for first loop. So let's write KVL for second loop. This is the direction of the loop, right? So this will be plus E2 minus I2 into R2, right? So next minus E1, right? Minus E1 and plus I1 into R1, which is equal to 0. Okay, so now we need to compare these two equations. Okay, or we need to identify the correct equation. Okay, so first one says E2 minus R2 minus E1 plus I1 into R1, we got, right? Here minus I1 into R1. So the first equation is wrong, right? And the second equation is also wrong, right? The third equation E2 minus I1 plus I2 into R wrong, right? The third equation is also wrong. The fourth equation E1 minus I1 plus I2 into R, okay, not R1, R, capital R, minus I1 into R1 equal to 0, correct. So the correct option is D. Okay, next question, question number 143. 5 equal resistances, each of resistance R, are connected as shown in the figure. A battery, here this is the given figure, okay? A battery V volts is connected between A and B. The current flowing in AFCEB will be, okay? So the given figure or the given circuit is Wheatstone bridge, right? Isn't it? So I can redraw this circuit diagram. Here this is point A, okay? Next point F, it is connected to the resistance R, right? And this point is C, right? This point is C, and then the point C connected to resistance R, right? Here the point P, right? Point B connected to E, right? Now F connected to resistance R, right? And it is connected to point, here this is E, right? So this will be point D, right? Then there is a resistance between E and D, right? And another resistance between C and D. Here the resistance R. Here another resistor between C and D and E. Okay. So now this one is Wheatstone bridge, right? Isn't it? So now take the ratio. Here R by R, R by R. It is 1, right? Or you can multiply this R to this R square equal to this R to this square, this R square. So which is, here the ratio is same, or the multiplication here R into R equal to R into R, right? So this is balanced Wheatstone bridge, right? So now I can redraw this circuit diagram as A, R, R, okay, then R and R. You can neglect this R, that is the resistance between C and D, because the potential difference is 0, right? Potential at C is same as potential at D, okay? Potential difference is 0. Now A and B connected to the battery of voltage V, okay? So we need to find the current flowing through AFCEB, current flowing through AFCEB, okay? AF, okay, CE or CE, okay, this point is E, AFCEB, okay. Here the resistance is same, right? 2R and 2R, isn't it? So current will divide at this point equally, right? So what is the value of current? The current is equal to V divided by 2R only, right? Why it is V by 2R? Here the resistance, total resistance 2R, and here total resistance 2R. The resistance is same, right? Here 2R and 2R, isn't it? Resistance is same. So at this point the current will divide equally, right? Isn't it? So I equal to V divided by 2R. The current flowing through AFCEB is V by 2R. So the correct option is D. Next question, question number 144. You are given a closed circuit with radii A and B as shown in figure, carrying current I. The magnetic dipole moment of the circuit is, the simple one, right? Magnetic dipole moment of the circuit, M equal to I, the current flowing through this circuit, into area A, right? Now M is equal to current I into area. Area will be here area of this one, okay, this semicircular loop in plus semicircular loop, right? So current into area is half of the area of this semicircular loop, that is half pi into A square plus half pi into B square. Now M is equal to half pi into I into A square plus B square. So the correct option is B, okay. Next question, question number 145. A 10 electron volt electron is circulating in a plane at right angles to uniform magnetic field 10 to the power minus 4 Weber per meter square. The orbital radius of the electron, okay, 10 to the power minus 4 Weber per meter square is 1 Gauss, okay. So here the kinetic energy of the electron is 10 electron volt, right? Here kinetic energy is equal to 10 electron volt, right? So it is circulating in a plane at right angles to the magnetic field, uniform magnetic field, right? Here the radius of this circular path is R. When electron moves with the velocity v in a uniform magnetic field, it takes circular path, right? So the centripetal force on centripetal force on electron is mv square divided by r, which is equal to, that is centripetal force provided by magnetic force, right? That is qvb, isn't it? So here r is equal to m into v divided by qb, right? mv by qb. We got the value of r, right? So what is mv? mv is momentum of the electron, right? We have the value of kinetic energy. Now what is the relationship between kinetic energy and momentum? The relationship between kinetic energy and momentum is p square divided by 2m. Okay, relationship between kinetic energy and momentum, K equal to p square by 2m. So p is equal to root of 2m Ke, 2m into kinetic energy, root of 2m into kinetic energy. P is mv, right? Now r is equal to mv is root of 2 into m is mass of the electron, that is 9.1 into 10 to the power minus 31. Okay. Ke is 10 electron volt, that is 10 into 1.6 into 10 to the power minus 19. Electron volt is 1.6 into 10 to the power minus 19 joule, whole divided by q. Q is charge of the electron, that is 1.6 into 10 to the power minus 19 into b. B is 10 to the power minus 4 Tesla or Weber per meter square. Now solve this, okay, you will get r approximately equal to 11 centimeter. So the correct option is C. Okay. Next question, question number 146. The length of a solenoid is 0.4 meter and the number of turns in it is 500. Okay, the length of the solenoid and number of turns are given, right? A current of 3 ampere is flowing in it. In a small coil of radius 0.01 meter, that is 1 centimeter, and number of turns 10. A current of 0.4 ampere is flowing, that is the current of 0.4 ampere flowing in the small coil. Okay, the torque necessarily to keep the axis of this coil perpendicular to the axis of the solenoid will be, here this is the axis of the solenoid. Okay, axis of the coil is perpendicular to the axis of the solenoid. Okay, so what is the necessary torque required, or the torque required to keep the axis of this coil perpendicular to the axis of the solenoid, right? So we know that torque tau is equal to mb sin theta. What is m? M is magnetic moment, b is magnetic field, theta is angle between magnetic moment and magnetic field. Okay, so what is the angle between magnetic moment and magnetic field? Magnetic field is magnetic field due to the the current carrying solenoid, right? Magnetic moment is due to this coil, right? Isn't it? So tau equal to mb sin 90 degree, right? M into b sin 90 degree. Sin 90 degree is 1, right? So it is just m into b. Okay, here m is equal to n into I into a, right? So what is n? N is number of turns in the small coil, right? That is 10. And what is I? I is current flowing in the small coil, right? And a is area of the small coil. Okay. Next, b is magnetic field due to the solenoid, right? Magnetic field inside the solenoid. So what is the magnetic field inside the solenoid? It's mu naught n into I. So what is the meaning of small n? The small n means the number of turns per unit length. Okay, not number of turns per unit length. Okay, now I can write b as mu naught into n by L into I, right? I is current flowing in the solenoid, n is number of turns, L is length of the solenoid, mu naught is magnetic permeability in vacuum. Okay, now here torque tau is equal to n into I into A. A is area of the coil, that is pi into r square into mu naught into here n dash. Okay, n dash, n is already taken, right, for small coil. Here n dash divided by L into I. Now substitute the values. Okay, tau equal to n. Capital N is here 10, right? Into I. I is 0.4, right? Pi into r square. R square is here the square of the radius. What is the radius of the small coil? Here the radius of the small coil is 0.01 meter, right? That is 10 to the power minus 2 meter. 10 to the power minus 2 squared is 10 to the power minus 4. Okay, into mu naught. Mu naught is 4 pi into 10 to the power minus 7 into n dash is 500 divided by L. L is 0.4 meter. Okay, into I. What is the value of I? I is here 3 ampere. Okay, so now solve this. You will get tau equal to 6 pi square into 10 to the power minus 7 Newton meter. So the correct option is A. Question number 147. An electric current of 30 ampere is flowing in each of two parallel conducting wires placed 5 centimeter apart. The force acting per unit length on either of the wires will be. Okay, so these are the two parallel wires. Okay, an electric current 30 ampere is flowing in each of two parallel conducting wires placed 5 centimeter apart. The force acting per unit length, right? That is F dash. F dash is equal to here force, that is magnetic force or the force on one wire due to the other wire is equal to I into L into B, right? Isn't it? Now force per unit length, right? That is F by L. F by L is F dash is equal to here force acting on second wire. Okay, this is second wire, first wire. So force acting on here the current on second wire into magnetic field due to the first wire. Okay. Now F dash is equal to B1. B1 is mu naught I1 divided by 2 pi R, right? R is 5 centimeter into I2. Now F dash is equal to mu naught is 4 pi into 10 to the power minus 7 divided by 2 pi into I1. I1 is 30 ampere, right? I2 is 30 ampere, right? Here mu naught I1 divided by 2 pi R. R is here, what is the value of R? R is 5 centimeter, right? 5 into 10 to the power minus 2, right? Now F dash is equal to here this is 2, right? So 3 into 3 is 9. 30 into 30 is 900, right? 900 into 2 is 1800, right? So 1800 into 10 to the power minus 7 divided by 5 into 10 to the power minus 2, right? So 5 3s are 18, then 360. 360 into 5 is 1800, right? Now 10 to the power minus 7 by 10 to the power minus 2 is 10 to the power minus 5. So F dash is equal to 360 into 10 to the power minus 5 Newton per meter, right? F dash is equal to 3.6 into 10 to the power minus 3 Newton per meter. So the correct option is A. Okay. Next question. Question number 148. A vibration magnetometer placed in magnetic meridian has small bar magnet. The magnet executes oscillations with a time period of 2 seconds in Earth's horizontal magnetic field of 24 microtesla. Okay, so this magnetometer executes oscillation, right? The time period of the oscillation T equal to 2 pi into root of I divided by M into B, right? I is moment of inertia of the magnetometer, M is magnetic moment, B is horizontal, Earth's horizontal magnetic field or the magnetic field, right? 24 microtesla. When a horizontal field of 18 microtesla is produced opposite to the Earth's magnetic field by placing a current. That is, B dash is equal to 24 microtesla minus 18 microtesla, right? So B dash is equal to 6 microtesla. The new time period magnet will be. Here from this equation, I can conclude that time period of the oscillation is inversely proportional to root B, right? So therefore, T2 by T1 is equal to root of B1 by B2. B1 by B2. B2 is B dash, B1 is B. Okay, that is 24 microtesla. Here, B1 is equal to 24 microtesla. Okay, B2 is equal to 6 microtesla. Now T2 divided by T1, T1 is 2 seconds. 2, T1 by 2 is equal to root of B1. B1 is, in this case, 24 microtesla divided by B2. B2 is 6 microtesla. So microtesla will get cancelled. So 24 by 6 is 4, right? Root 4 is 2. So T2 is equal to 4 seconds. So the correct option is D. Okay, correct option is D. Question number 149. To convert 800 millivolt range millivoltmeter of resistance 40 ohm into a galvanometer of 100 milliampere range, the resistance to be connected as shunt is. That is, we need to find the shunt resistance. Okay, here G equal to capital G equal to resistance of the galvanometer, capital G equal to 40 ohm. Okay, so we know that Ig into G is equal to I minus I minus Ig into G, right? So let us find Ig. Okay, so what is Vg? Vg is 800 millivolt range, millivoltmeter, right? 800 millivolt range, millivoltmeter. Now Vg is equal to 800 millivolt, right? And the value of G is 40 ohm, right? Now Ig is equal to Vg by G, right? So Ig is equal to Vg, that is 800 into 10 to the power minus 3 divided by G, that is 40. So 0, that is 10, 10 will get cancelled, it will be 20, right? So Ig is equal to 20 milliampere, right? And the I is 100 milliampere, right? We need to convert 800 millivolt range, millivoltmeter of resistance 40 ohm into galvanometer of 100 milliampere range, right? Now I equal to 100 milliampere, right? So here Ig, that is 20 into 10 to the power minus 3, okay, 20 milliampere, okay, 20 into 10 to the power minus 3 into G. G is here 40 ohm, right? 40 into, equal to, here equal to I minus Ig into G, right? I is 100 milliampere, 100 into 10 to the power minus 3 minus Ig is 20 milliampere, 20 into 10 to the power minus 3 into S, right? 100 minus 20 is 80, right? 40 into 20 is 800. So 800 into 10 to the power minus 3 divided by here 20 minus 100 minus 20, that is 80, 80 into 10 to the power minus 3, okay, which is equal to S, right? Which is equal to S. So now 10 10 will get cancelled, 8 tens are 80, 10 to the power minus 3, 10 to the power minus 3 will get cancelled, S equal to 10 ohm. So the correct option is A. Okay, question number 150. The magnetic needle is kept in a non-uniform magnetic field it experiences. So when you place magnetic needle in a non-uniform magnetic field, it experiences torque, okay, it experiences torque as well as force, okay. So option A is neither force, okay, first one is wrong, the second one is also wrong, the third one wrong, the fourth one a force and a torque, correct. Option D is the correct answer, right? Okay, thank you so much If you love this video, please like and share. And if you want to watch more such kind of video or such type of video, please subscribe. Thank you.